The second Kepler's law is a statement about how the speed of a planet or any other body, as it turns out, as explained later on by Newton, revolving around the sun changes depending on its distance from the sun. So the first panel here is a statement, it's the first Kepler's law, that the planets move along elliptical orbits with sun at one of the two foci. The second Kepler's law tells that the speed of the planet along its orbit varies in a very precise way. And that is that the line joining the planet and the sun sweeps over equal areas and equal times. So if I take a planet here, say close to its perihelion, right, and watch how much it travels over 6 months, and then I measure or calculate the area that this line joining the planet with the sun sweeps in 6 months, and then I do the same thing later when it's near the aphelion, I'll find out that these two areas are the same. But what that really means is if these two areas are the same, right, then basically the length of this arc here, when the planet is closer to the sun, has to be longer than the length of the arc here. If these two kind of triangles or slices of a pie are to have the same area, then this one here that is longer has to be more skinny, right, than this one here. Well, that tells me that when the planet is closer to the sun, it travels longer in a given time, say in 6 months, than it does when it is at a greater distance from the sun. That tells me that the planet's speed is higher as its distance from the sun is smaller. So when the planet is very close to the sun, it moves very fast, and then when it's at the greatest distance from the sun, it moves more slowly. So that's the essence of the third Kepler's law. Okay, so to redraw this diagram, so say, of course, this is exaggerated because none of the planets has an orbit that is elliptical to this high degree, but I will exaggerate in order to make the point. So here is the sun, right? So basically, what it's saying is that over equal intervals of time, this line that joins the planet and the sun will sweep over equal areas. Right? These two areas, and this is also area swept in 6 months. Okay, the only way that can be the case if closer to the sun, the planet travels longer distance in a given time, 6 months, than here. And vice versa. It drops, the speed drops as the distance from the sun increases. So that's basically what you need to remember. Never mind, you're not going to do any calculations yourself to remember this area law, right? But the implication is that when the planet is close to the sun, it moves faster than when it is at a greater distance from the sun.